Welcome. Well, this is a weird video, definitely. So, as you already read, yeah, this is about the atom and not having a nucleus. Now, yeah, you would say this is probably bullshit. And it's, I could claim probably like I've been adopted by aliens, which I haven't, or I've discovered a new mountain in the Himalayas, which I also haven't. But it sounds like this. But you will see the atom does not have a nucleus. I'm serious about this. Physics has been living on a fantasy for, well, what, no, 1911, it, 113 years, 114 years, that physics actually believes there is a nucleus. And it's all based on the single experiment by Rutherford, which, well, at the time was valid. Well, almost, but it was valid. Um, no, actually it wasn't, but from they are not to blame. They made some mistakes, which they are actually not to blame. But once in something like 1939 or 38, um, nuclear fission was discovered. This experiment is actually definitely invalid. But the experiment was valid in 1911. The article was already invalid. I will show all of this. Okay. I don't want to fuzz around and well, at the end of the video, I will tell you, and there won't be any cuts. It's just straight, basically not streamed, but recorded, and I'll publish it uncut. Okay, so let's have a look at how we picture atoms. Okay, you will see none of these is actually true. For a simple reason, we know they are all showing circling electrons. And circling electrons that's an accelerated motion. This accelerated motion loses energy, and so the electron should spiral into the nucleus. Okay, that is really known for a long time, and there have been arguments against this. The main one was Niels Bohr, who postulated um, basically quantum levels, and nowadays it is more like it looks like this. So it's orbitals. Conveniently, yeah, and you see here, you see the p orbital. Um, might be something like, well, no, actually, sorry, this is an imagined nucleus. And you will see there are already a lot of problems with our imagination. So we don't know, and the normal explanation is the atom cannot actually pictured. It must be because it's quantum mechanics and you cannot draw quantum mechanics. Well, so let's bring this down. Let's bring this down. Okay, so this is basically an atom. Well, it's the same as before. You've seen this. There's a nucleus inside. There's the red one, and then the outer shell. What you immediately see is there are only two possibilities. The shell can either be closed or the shell can either be open. Let's have a look at the shell be open. Like this. Okay, what would that mean? That would mean there are attracting forces between the shell and the nucleus. So there must be a counterforce for this to be stable. So they must rotate. That's the only way. There is no other way you can make this stable. And that's already the end because, yeah, if I draw this as a line or as a single dot like this, no difference. This is impossible. Quantum mechanics, we'll deal with quantum mechanics in a second. Really, it won't be long. Um, so there is no possibility of this. So let's do this back. Okay, so closed. A lot of physics actually explained to me, yeah, well, the electron is smeared around the nucleus. Nope, it can't be. For a simple reason. Yeah, well, these are the forces. So you see the outer, well, here you see it. You see this outer dotted circle, which represents an imaginary hull. And if this is closed, the circle is closed, we have a problem with Gauss' law. Because Gauss' law actually needs a representative at any point of the charges inside. And that is not given because the field lines from the inner positive core cannot reach out because this is closed. Well, this could be some, because we claim it's quantum mechanics, and so this could be some really weird function where the field lines could sneak through. Nope. There is a mathematical proof that I would probably be not capable of doing, and most of you will probably not be capable of doing. It's called the Jordan curve theorem, which states clearly that the inside and the outside is divided into two zones where there's no connection between them by any pathological curve as long as it is continuous. The electric field is continuous, so the Jordan curve theorem applies. And there's a 3D extension. You can read about it. Let me just show you. Let me show you. Yeah. So here we have the Jordan curve theorem, and then the proof and generalization. And so this is mathematical realm. Absolutely foolproof. That is valid. Now you can start to see the problem. If it's open, you have a connection. Gauss' law can be fulfilled. If it's closed, Gauss' law is impossible. But if it's open, we already established. Let me show you again. We already established there is no way for the inner field lines to get outside, and therefore you can never have a neutral stance, because if the charges in the shell and the nucleus are equal, the surrounding should be neutral. Okay, now what does this? But it doesn't matter, because people will tell you, you cannot argue classical mechanics. It's quantum mechanics. And the first thing that quantum mechanics is actually showing you is atoms. And yes, I have been internally, I questioned this for a long time, but there was no way I could argue against quantum mechanics until I found the most simple and devastating argument that will kill the whole quantum mechanics argument. It's so simple that, yeah, you will laugh at it. I just showed you there is no classical mechanical model. No way, and nobody has ever come up with one. Yeah, because classical mechanics cannot explain it, and you read this everywhere. The problem is, if there is no classical mechanical model, there cannot be a quantum mechanical model. You cannot just claim there is quantum mechanics. How do you ever want to prove this? So I'll try to show you a little bit, well, actually to explain you a little bit. Let's take the pinnacle of quantum mechanics experiment, the double slit experiment, um, possibly with electrons, or as Max von Laue did. You get wave behavior of particles. And if you do the same with, let's say, a tennis ball machine and two slits, you do not get wave behavior. So you have an experiment that has classical mechanical rules that predict A. Then you do the experiment and the outcome is B. Okay, that is a valid reason to tell, well, we have a quantum mechanics effect. Totally fine. The problem with the atom is there is no A. You don't have a model. You cannot just claim something that is like the moon with stars inside. So these famous pictures, I think Matt Parker actually showed this, that you have a half moon and then in the other half you see stars. So it's like this is not a basis for a scientific argumentation. There is, and therefore, as long as you do not have a stable model for the atom that you can compare against, you can never claim this is quantum mechanics. It's impossible. Now you can say, well, we are seeing spectral lines, and that's a clear sign of quantum mechanics. No, it's just an interpretation. You just interpreted it the way, because what? Take a monomode fiber optics. There's just a single line. Is this quantum mechanics? No, it's not. It's just a monomode fiber optics. Nobody would claim this is quantum mechanics. So the problem is the whole idea of quantum mechanics and all the mathematics on top of it is just what is called ex falso quod libet, which means from false follows anything. So because your underlying logic is fundamentally flawed, you created a model against nothing, which is mathematically and logically false. You suddenly can compare anything. And that actually explains why this model is so successful. Yes, of course. There are these fun mathematical equations where you start with an equation, then you make it more complex, and then you divide a little bit, and you multiply a little bit, and you square a little bit, and in the end, you show that 17 is equal to 16. And each step seems to be correct. The way to do this is at this division, which is usually a little bit more complex with x and y's and variables, you just divide by 0. So you put in a faulty step and suddenly you can prove that 16 is equal to 17. And the same way has been done with physics. It's totally out of my imagination, and I still cannot grab how something that stupid could happen to physics. I mean, now we I hope this is basically starting an kind of a discussion and a real discussion. Probably what will happen is it will be ignored because it doesn't fit into the narrative. But yeah, you can imagine this actually brings down the whole standard model because no nucleus, no quarks, a little bit problematic. I don't know what effect it has. It is also no new theory. I don't know what it really is. I had some ideas, and I will make another video where I present my ideas, but these ideas are wrong. But the ideas actually triggered that I found out, hey, the whole story about the nucleus is wrong. It's just it I don't know what kind of effect this is going to have. A lot of textbooks have to be rewritten and all the kind of stuff, and I don't know. Well, I think physics will try um, to ignore it. No, you can see this by the way that I tried to publish it. Nobody wants to publish something like this. This is just too inconvenient. But okay, maybe it actually brings back physics. Because you will see my ideas, which were wrong because it was just fun. And actually, I'm not a physicist. I just do physics for fun. Um, yeah, uh, these ideas also not correct. They triggered some really interesting ideas, and you will have a lot of fun. And I hope you will watch the second video about this. But I want to reiterate this again, how the argument actually goes, because a lot of people will not believe it. So let's do it again. So there is no classical mechanical model for an atom with a core or a nucleus. It's not there. Nothing is stable, and just because we do some nice fancy pictures, that does not make a valid classical a valid physics model. That's not the case. So you can prove something like this with a positive nucleus and a negative shell cannot exist by showing it must be either open or closed, because that's what the Jordan curve theorem gives us, and its extension, the Brouwer-Jordan separation theorem. That is what mathematics gives us. And therefore, we have already covered the case of it's open. Then it's like this, which doesn't exist because energy loss and stuff like this. And closed can also not exist because of the violation of Gauss' law. Very simple. Okay, if this doesn't exist, then there cannot be a classical mechanical model. This step will probably create some debate. So I will iterate on this step a little bit more and evaluate it a little bit more. Let's say I'm wrong. Classical um, physics claims quantum mechanics is the basis and classical mechanics can be derived as an approximation. That's not me. That is, let me show you. That is originally, whoop, Okay? Quantum mechanics can describe many systems that classical physics can't. Classical physics can describe many aspects of nature in an ordinary way, but but it's not sufficient for describing at very small microscopic scales. Quantum mechanics can be derived from quantum mechanics as an approximation that is valid at ordinary scales. Okay, so classical mechanics is dependent on quantum mechanics. But that also implies there is a back compatibility, at least for us humans. Maybe it is not the case, but it must be, because it is not abrupt. So it's not like you have quantum mechanics and then in a blink of an eye, it switches and it is classical mechanics. There are enough experiments out there that show there is a zone where we gradually move over to quantum mechanics behavior. And that means quantum mechanics is dependent on classical mechanics. Classical mechanics is dependent on quantum mechanics because it's derived, but also it defines behavior of quantum mechanics. And therefore, quantum mechanics has a dependency on classical mechanics. So they depend on each other. So now you take away one of them, then the other cannot exist either. You cannot just claim, well, it looks nice and there's a lot of mathematics, but as I said, paper doesn't blush. You can write any valid mathematics, and there's no big deal. It just is pure fantasy. And that is what happened in this case. I don't know why nobody pointed this out. I have no idea how something really, really basic like this could ever be missed. And it's not like, oh my God, uh, yeah. So the argument, it's actually ChatGPT was really helpful because ChatGPT is a fucking dumb, as we all know. These kind of things, it is not intelligence. So ChatGPT actually they argued, well, we see spectral lines, stuff like this. So they argued from the quality of traits that we see in an atom, and therefore they concluded it must be quantum mechanics. But they then also agreed that in this case, if the sun is round and yellow and the cheese is round and yellow, then the sun must be a cheese. Yeah, which is obviously not the case. Or you could actually try to make the quantum mechanic more argument for the Eiffel Tower. The Eiffel Tower is actually flying around Paris, and every time it is observed, it is where you see it. Okay, I mean, this is total bullshit, of course, but without the argument that something like this doesn't exist in our classical mechanical world, you're having a hard time disproving this. And that was a problem that I had. Everybody was claiming it's quantum mechanics. You're not allowed to. What? You are telling me in physics you are not allowed to think in classical mechanical terms? Well, yes, I am. And you see, if I come up with something like the double slit experiment, I can build the double slit experiment with tennis balls. And I can show, yeah, you don't get wave behavior. Then you do this with light or with electrons on again, as I said, the famous experiment from Max von Laue. And then I get a wave pattern. So I have a valid approach to say, hey, this is quantum mechanics because here's my experiment. So show me your experiment for the atom. Show me. There isn't any. It's just pure assumption. It's just interpreted in, well, we see this, so it must be this. There is no substantial experiment that actually shows this. Okay. Now, but we have the Rutherford experiment. Well, yes, we have the Rutherford experiment. But the Rutherford experiment was, as I said, at the time, it was an ingenious experiment. Undoubtedly, I don't want to blame the people at that time. Nobody is blaming um, Aristoteles for, or was it? Yeah, Aristoteles for observing that everything comes to a stop. Nobody's blaming Ptolemeus for as the geocentric system. It's stupid to blame people for the knowledge at that time. And at the knowledge at that time, the atom was still a tomos, which means Greeks for undivisible. So if you take something and you shoot it at something that is undivisible and something comes back, what is your conclusion? Yeah, it's what you shot it at. But if you shoot a bullet against a pumpkin and something comes back, do you assume this is the bullet? No, it's probably a dollop of pumpkin. And this means we don't know what's coming back. And it's kind of interesting. I asked physicists and said, hey, do we have any proof that these are alpha particles, what we are measuring? Because we are not measuring alpha particles. What we are measuring, even with modern Geiger-Müller counters, is ionization. And there's a lot of stuff that causes ionization. And I'm not talking about cosmic rays because these experiments are well shielded. We can exclude this. It's just what is coming back has never been investigated to be alpha particles. It's just an assumption. We see something, we hear a ping, so it must be an alpha particle. It might be an alpha particle, but there is no proof. It could be a proton, could be an electron, could be even a positron. We don't know. It must be something that is charged, yes, we know, but nobody put an electric or magnetic field in order to deflect them and then try to get the mass of them or something like this. No, the experiment is taken as it is, and it's like the journalist Brady Haran, he calls it the folklore of physics. Okay, so we have now fairy tales in physics as the basis of our science. Interesting aspect. But because it actually is. The experiment is inconclusive. And there's a lot of things that are inconclusive. It's not just what is coming back. We actually don't know if the gold atoms are getting fissioned. We don't know. We don't know if we just get electrons out of them or anything like this. Okay, so the atom does not have a nucleus. That is very, very clear. What it is, I don't know. I mean, there are thousands, if not millions of physicists out there who can actually investigate. I will present some ideas which led me, but I see this more like, you see, radioactivity was actually discovered because Becquerel, who is now honored for his discovery, got it wrong. And because he got it wrong, that actually um, inspired other physicists to look in this direction, and then they found something different, and they found something new. But it was as there's an interesting book on the history of early nuclear physics, I think, from written by a Hungarian or Czech author, um, out there. You can buy it on, I think, on Google Docs or something like this. So it is possible to buy it, and they describe it in there that Becquerel got it wrong, but because everybody believed that it was right, there were experiments done which actually led to new discoveries that would have probably taken lot more time to find, would have Becquerel got it right in the first place. Things like this happen. So my idea, what it was, is actually wrong, but it triggered that I started to doubt the actual atom model. So, I have a few more things about why um, this must be wrong, and it's some circumstantial. So think about the mass distribution inside an atom with atomic nucleus. Almost all the mass is concentrated in the nucleus, right? Now, think about you are building snooker or pool billiard balls that have this mass distribution. It's a little bit hard to build them. As I said, there is no actual model, but you could ignore the charges and just take, let's say, for a table tennis ball, and you strap with some rubber. Uh, you strap a lead core inside, something really heavy, and then you play pool or snooker. Yeah, some kind of interesting, huh? Because everybody agrees, yes, inside the atom, gravity does not play a role, but inertia does. So, and we know atoms are bouncing into each other's all the time. How do you explain this? Because in order for the outer lighter shell, which is 3 orders of magnitudes lighter than the nucleus, to move the nucleus, you need extremely strong forces. Well, you could say, well, we have a strong force, a really strong one, which is the electromagnetic force. And it's known to be the second strongest force. Well, then there's no nucleus. There's likely no strong force and no, but we will, for our normal world, we have the comparison. We have gravity and we have the electromagnetic force, and the electromagnetic force is much stronger. Okay, but the problem is for impulse propagation, you need forces that do not attract each other. So they repel each other. So let's take two magnets. You can put South Pole against South Pole, and then you can push the other magnet without even touching it by pushing the other one, as long as South Pole is opposite of South Pole, because South Pole repels South Pole. We know this, and the same is true for electric charges. A positive charge will repel a positive charge, and a negative charge will repel a negative charge. But in the atom, there is no opposing charges across an atom. If you take a straight line through the center, you hit negative, positive, negative, and they're all attractive. There's no way you can propagate any kind of energy like this. So, I mean, it's totally obvious, and I don't know why people did not realize this. Then you have the problem that, well, everything centered, that should lead to a disk. Look at something like the solar system or a galaxy. When you have a large central mass and and a fraction of this mass and on the outside, they all tend to be disks. Well, I don't think atoms are disks. Actually, oh, they look more like water drops. And actually, this is interesting. The idea that I had actually supports this. That the atom behaves a little bit like water drops. But as I said, the idea that I had is wrong. Um, this doesn't really. The only thing that I can definitely say is no nucleus. Definitely, this is pure fantasy. And unless you come up with a stable model in classical mechanics, there will be no quantum mechanics model. And this will be, of course, a debate. People who don't believe this, because, yeah, the word belief is here really, really big. It's a matter of belief. Unless you come up with something that explains why there should be a quantum mechanical model without a classical mechanical model, also there's a clear dependency between the two, you have a problem. Well, you will continue to ignore it, you will continue to do fancy mathematics on top of it, and yeah, I get the point. But the point of this video is not is basically to document it. Now it's documented, and a lot of people actually know about it, and probably some physicists will watch it. And you can leave your comments and show why I'm wrong. I mean, maybe I am wrong, though you will be able to challenge it. But let's try it again. Where you want to get actually into, because you can really, really put the whole argument in a single sentence. There is no stable model for an atom with a core, no classical mechanical stable model with an atom with a core, and therefore, because these two are interdependent, there cannot be a classical mechanical model. And that's it. So now this is I hope I'm going to attract a little bit people from mathematics and from philosophy, because they deal with these kind of logic stuff as well. And yeah, what it really is, I have no idea. I thought I had an idea, but it's wrong. Well, actually, I don't know, it's wrong. It has a lot of fits, the idea, but it has one huge, huge problem. But this will be another video. So, yeah, well, I forgot one thing. One is really interesting. One argument that might be, well, we have nuclear fission, and we have proof that we have atomic bombs, and we have nuclear power plants. Okay, which is not a complete argument, because if I go for the Greek elements, fire is an element. And if I claim I have fire, that is not a proof it's an element. Actually, if you look at the history of atomic bombs, that supports actually my claim. Because surprisingly, the first bomb they ever exploded worked. Then they dropped two of them of two different types. So the second one was a different type. They worked as well. And it took something like 25 or 30 until I think there was one incident where something failed. But then the Soviets, they tried and they hadn't a single failure. Now, for a modern technology, for a really modern technology, this is kind of strange. I mean, if you look in the history of new technologies, it's riddled with failures. So why didn't any of these atom bombs ever fail? If there were failures, they were circumstantial, like um, something broke off the wing, they lost something, anything that has nothing to do with the actual nuclear explosion. These things failed, just like modern technique does. But the fission itself, it did never fail. Also, there was one incident, I wrote it, but we have over 1,000, and I think one incident where it failed. So that's less than 0.1%, which is incredible. I don't know if you have any other um, modern technical invention, which you could say fission is. Also, it's not a nice one, but that ever failed in such a low rate. And that is, well, kind of strange. Now, if there is no nucleus, the mass must be logically distributed in a different way. That means you're not fissioning the nucleus, you're fissioning the atom. If you're fissioning the atom, we certainly not deal with 10 to the minus 15, we only deal with 10 to the minus 12, something like this. Or even 10 to the minus 10, I think. I think something like this. I think, sorry, I got it. I think I got the wrong. I think 10 to the minus 10 is hydrogen, which is 1 angstrom. And then 3 orders of magnitude is 10 to the minus 13, which is probably then in the area. But nevertheless, so you're dealing with 3 orders of magnitude more. So you had a massive overcalculation. So the error margin has been basically driven to almost zero. That could explain it, which is not a proof. It's just a circumstance. So it's just because people come with something that is not a proof, and they say, "Well, okay, yeah, but how do you explain that?" Huh? Um, so I think that is, yeah, mm, pretty much it. I will conclude this here. I, s- I see this basically as a documentation. There won't be a big series about me rolling up physics. I do this for fun, and actually I want to get past it because it was fun as long as I did it. But when I tried to talk to physicists, they all started to um, basically derive the they didn't like it. Let's put it mildly. They did not like it, especially when people tried to explain me how Gauss' law worked, and then they found out it was wrong. Then they just kept silent and stuff like this. Or if I asked a question, they asked me to take the question back and stuff like this. So it was not nice. But let's see. I don't expect the older physics to, in any kind of change their stance. I expect young physicists to maybe take this and start new experiments, because that's the only thing how you bring a theory like this down. My video is just for documentation. Nobody will really probably care about it. Um, but let's see. So the next one will be fun because it is my fantasy model that I actually put in. It has a lot of interesting fits, and in the end, I will show why it cannot be. Just like I showed this one, there cannot be a nucleus inside an atom. Impossible. So I thank you, and maybe I see you in the next video.